Okay, so the discriminant roots are the coordinates of a graph where it crosses the x-axis. For quadratics, we can either have two roots, 1, 2. We can have one root, so that means it touches the x-axis once. Okay, so it touches once. You can also have 0 roots. Okay, and I'm going to put 0 real roots, specifically for HL. Yeah, all right. That's okay. I saw you. All right, so 0 real roots, that means it crosses the x-axis. How many times, Frankie?
0 times.
0 times, so it's going to look like that, okay? Does not cross the x-axis. Those are our only options for quadratics, okay? You either have 0 roots, 1 root, 2 roots. Okay, and we're going to put if there are 2 roots, we say they are 2 distinct real roots. Okay. There is 1 root. We say there are 2 repeated real roots. Okay, and you'll see why in a second. Or you could even say equal real roots. Okay, so I want you to find the roots of, and I'm going to give you the method as well I want you to use. So let's do factorization for the first one. Find the roots of, let me make something up, nice and difficult. So I want us to find the roots of these equations, okay? Using the method that I've put up, okay? So the first one is y is equal to 3x squared plus 7x minus 6. If I'm finding the roots, the first thing I want to do is to put it equal to, make it equal to 0, good, because remember that's, we're finding when y is equal to 0, okay? Alright, so I'll give you a few minutes to have a go at those. Okay, ready to have a look at some of these? Let's do the first one, okay? I'm going to use my method, that is foolproof. Just remember it, I want two numbers that multiply to give. No. Nope. Negative 18, because we've got a 3 in front of the x squared. The same two numbers have to add to give. Positive 7, what are the two numbers? Nope. 9 and negative 2, okay? 9 times negative 2 is negative 18. 9 add negative 2 is 7. We just take those numbers and we plug them in. I can't emphasize enough how important it is that you get your head around this and are able to do it, okay? Then you, yep, and factorize out. Right, so what can I take out as a factor for the first part? What goes inside the bracket? X plus 3. I write down the same bracket again and then look at it and think, okay, what do I need to write out here so that when I expand it, I get negative 2x take away 6. Negative 2, right. And then I finish it off by just doing my x plus 3 and 3x minus 2. You got it? Okay, good. And then to finish off, I need to write down what the roots are. So from x plus 3, what is the root?
Negative 3.
And from 3x minus 2?
2 over 3.
Right, good. So I've got two real roots, yep.
Yes.
Two distinct real roots. Is that okay? Please learn it, learn the method. All right, second one, completing the square. Talk me through it. Frankie, what do I do first?
Bracket, x squared minus 6.
Yep.
X plus 9 in bracket. Or plus 6 over 2
Yes.
squared
Good.
minus 6 over 2 squared
Okay.
plus 9.
Okay, good. So you add on half the middle term squared. Then, sorry, I want to put this equal to.
You take the first 3 terms.
Yep, take the first 3 terms and that combines into x.
X minus 6 over 2
Yep.
squared.
Yes. I could write it as 3. 6
Yeah,
over 2 is 3. Sorry, that's not correct.
No,
Sorry. X minus 3 squared. And then I've got minus 3 squared plus 9.
Yeah.
So what is this giving me? What's this combined to? 0. Yep.
Yeah.
So essentially I've got x minus 3 multiplied by x minus 3. So what are my roots? 3, okay. So I've got 2 roots, but they're both 3, but they're repeated, okay. So in this case I've got 2 repeated or equal real roots. Is that okay? So this graph would touch the x-axis how many times? Once. And then the last one. It needs a quadratic formula.
is greater than raindrops mass.
All right, so minus b. So, put these numbers into the formula for me, Jesse.
I put it as 4.
Yeah, because it's negative, negative.
Yeah.
Plus and minus.
Minus the square root.
Yep.
And I kind of like jumped steps, but it would be negative 4 squared, which I wrote down as 16.
Yep.
Minus 4
Yep.
times 1 times 5.
Yep. All over.
2. 2 times
Yep.
1.
So
and
I
then
got
I got it down to 4
Yep.
plus or minus the square root of negative 4, because 16 minus 20, which is 4 times 5.
Yep.
Over 2. And that's as far as I got.
Good. Why is that as far as you got?
Because you can't take the square root of a negative number.
Good. Okay. So this tells us, yes. So as you cannot take the root of a negative and get a real answer, this quadratic has no real roots. And yes, Jaden, sorry, you asked if you do use the quadratic formula. What I'm talking about.
Okay.
It's just like an extra step. It's not hard. For those of you that are interested, which is everyone, of course.
Well, for higher level.
If I'm down to this, 4 plus and minus the square root of negative 4 over 2. These are my roots, okay? We're saying there's no real roots because I can't take the square root of a negative number. You put that into your calculator, it's just going to come up with error. What a particular mathematician said was, okay, well, let's just actually then define the square root of negative 1, and let's call it I, okay? Which stands for imaginary, okay? And using our knowledge of surds, square root of negative 4 is just the square root of negative 1 multiplied by the square root of 4, yeah? So if I was to work out the square root of negative 4, it's actually what? 2i, good, because the square root of 4 is 2. The square root of negative 1 is I. So what I would actually get here is standard, don't need to worry about writing this down. Just you can watch just out of interest's sake. So I would get down to this. Okay, the square root of negative 4 would become 2i, which when I simplify it, I can divide 4 by 2 and get 2. I can divide this 2 by 2 and get just 1. So that would be the complex roots. I would get 2 plus I and 2 minus I. But we'll take more of a note on this. Okay. If these are the roots, sorry, I'm just going a bit off topic, SL, but if these are the roots,